Hello everyone, welcome back to my channel, Tamil Quality Inspection. Today we are going to discuss the topic on CSWIP 3.1 practical exam acceptance criteria and defect identification. So, how to identify the defect in the welding specimen and what are the acceptance criteria for the defect type. So, let's dive into the topic. So, first defect we are going to discuss that is excess weld metal. So you can see the photo. This is a excess weld metal. So the weld metal they filled excess above the parent plate surface. That is a excess weld metal. So we can call it as weld reinforcement weld cap. So always we have the criteria acceptance criteria for the weld cap or excess weld metal. So to check the height of the excess weld metal, we can use bridge cam gauge. So by that only we can check the height of the gauge. During the examination, they will provide the bridge cam gauge, so you can use it. Always keep the bridge cam in the lower side of the uh, plate. If the plate have any distortion, first you have to check where is the lower portion. You can see this is a lower portion compared to this side. So you have to keep here and you have to check the height of the accessible metal. Always keep in memory. You have to keep in lower side of the plate. If if you see any distortion in the plate, okay. In the examination, you have to identify the excess well metal and you have to verify with the acceptance criteria, that is group A and group C. You have to check the criteria which they mentioned in group A and group C. That is enough, no need to see group B. Okay. In the bridge cam gauge, if you measure more than 2 mm, it is rejected in group A, and in group C maximum 5 mm they are allowing. Okay, first directly measure the height and measure the value. If it's above 2 and below 5, directly go and reject in a group A, and group C it will be accepted. If you measure above 5 mm, like 6.5, directly reject group A and group C. Directly put reject. Okay. I think you understood about the excess weld metal. Then underfill. The definition of the underfill: the weld metal below the surface of the parent metal. If you notice any weld metal below the surface of the parent metal, it is near to the groove, it's middle of the weld, it should consider as a underfill. Here you can see this is lack of fusion also and underfill also. Wherever you are noticing lack of fusion or slag inclusion, there will be underfill. There you should consider as a underfill. Okay, it's below the parent metal. Okay, that weld metal is below the parent metal. Okay, if you see any slag inclusion in the middle of the weld, that also considered as a underfill. Okay. Here in group A, underfill is not permitted. In group C, you have to measure the length. Okay. Just you can measure by visually also. That the length is more than 5 mm. No need to measure it directly. You can reject it. Okay. Now you can see this length is more than 5 mm. By visual inspection we can identify it's more than 5 directly. You can go and reject it. Don't need to measure, no need to waste your time by measuring. Okay, if you see by your naked eyes that is more than 5 mm, directly reject it. Okay, you understood, I think so. And here you can see here, here also the well metal is below the parental. So here also you have to consider as a underfill. And keep in mind, if you notice lack of fusion or slag inclusion in middle of the weld, and if you notice the weld metal is below the surface of the parametal, that is considered as an underfill. And directly you have to verify, you have to check with the criteria whether it's accepted or not. That's all. Okay. And the slag inclusion, in slag inclusion, okay, you can see, okay, non-metallic inclusion, it's like a cement. It's like a cement. You can see there is a color differentiation between the weld and the slag inclusion. And you can see some small holes in the slag inclusion. So you can confirm there is a slag inclusion. If you notice any non-metallic inclusion in the weld or between weld to parallel metal, okay, between weld and parallel metal, if you notice any non-metallic inclusion, that is considered as a slag inclusion. Here in this photo you can see, so there is a difference in color. So it's like a cement, and you can see small pores. Okay, here if you notice any slag inclusion, then you have to verify with the criteria. You have to check with the criteria whether it's accepted or not. In group A, it's permitted. Is sorry, it's not permitted. In group C, you have to measure the length. It can be continuous or intermittent. If it's intermittent, if you see that is that the slag inclusion are having in a gap, with a gap, then you have to measure the total length. You have to add each length, and you have to check with the criteria. Okay, that length should not go beyond 20 mm. If it goes beyond 20 mm, it's rejected. Directly you can reject it. Okay. That is a slag inclusion. That is about slag inclusion. I hope you understood. Then undercut. Undercut, you can see in the base metal also, near to that weld. Okay, some of the base metal get melted. That is a undercut. And if you have a two run of the weld metal, and there also you can see undercut. You can see the undercut between the weld metal. If you have a two run, you can see the undercut here. Okay, then you can see near to the toes are the weld metal. Here you can see that here. And this one is groove melted into the parent metal. Here that the groove is melted into the parent metal. That's also you have to consider as undercut. And you can see near to the toes here, near to the toes, that also considered as a undercut. This is a toe. Here also you can see some grooves that are melted. That is also you have to consider as a undercut. Sometimes have uh, two interrun. You can see some edges are melted. That is also considered as a undercut. In group A, if you notice the sharp indications that the edges are sharp, then it's rejected in group A. Okay, and that sharp corner should be blended smoothly. That blend is required, smooth blend, and you have to measure the length. If the length is more than 5 mm, either continuous or intermittent, it is rejected. And the depth also should not go beyond 1 mm. That is for the well face. Only these are the this criteria for the weld face. If you find any undercut in the root, that is considered as rejection. In root, undercut is not permitted. Okay, directly you can reject it. If you find any undercut, that is rejected. Either either sharp or blend. If you noticed anything, it will be rejected. Okay. Then group C. For group C, you have to measure the length. Okay. If the length is more than 25 mm, the length is exceeded more than 25 mm, either continuous or intermittent, it is directly rejected. And here in root, they are allowing the undercut if the length is less than 25 mm, but the depth should not go beyond 3 mm. Okay, but in group A, in root, undercut is not permitted. But in group C, undercut is permitted in weld face and root if the length is less than 25 mm and depth is less than 3 mm. Okay, uh, that undercut, this defect, you can see either face or root. So you have to check in both the surface. Then poor stop and start. Okay, if the welder is welding from here to here, then afterwards he is starting from here to here. So he didn't start from here. So there is a crater is there. You can see the crater. If you noticed any crater, that is stop and start. That is poor stop and start. Okay, this defect you can see in restart. During the restart, this type of defect will occur. It's basically due to unskilled welder. Okay, if you noticed any crater, you have to measure the length from edge to edge. Okay, from this edge to this edge, where it's get finished. Okay, you have to measure from this edge to this edge. So once you measure, if it's the length is more than 30 mm, then it's rejected in group A. If the length is more than 10 mm, it's rejected in group C. Okay, you can see here also crater is there. So here also you have to measure it. Okay, okay. Well, you are measuring. Okay, the if the during the time the length is less than 10 mm, then no need to consider as a rejection in group A and group C. Directly you can accept it because it's less than 10 mm. Okay, so you can directly you can reject it. Sorry, directly you can accept it. Then lack of sidewall fusion labs and cold labs. Definition. If you notice any incomplete fusion between the well metal and base metal, this is a well metal and this is a base metal. That well metal is not fused properly. There's a gap is there. So there is a lack of sidewall fusion. Sometimes you can notice if you are welding in a, if you have a two bead, okay, you can see here two bead. Okay, this two bead in the middle, some of the portions not filled, not completed fully. So it's called as the interrun fusion. So if you noticed any gap between the two run, it's not fused properly, then it's considered as a interrun fusion. Okay, and this lack of cellular fusion, if you see lack of cellular fusion, it should consider as a underfill also. Okay, I think you understood. And second thing, if you noticed any edges, any one side of the edges of the parallel metal, it's not fused properly with the weld metal, that is also lack of fusion. So in group A, it's not permitted. In group C, you have to measure the length. That length should not exceed beyond 15 mm, either continuous like this, either continuous or intermittent. Okay, intermittent. So it should not go beyond 15 mm. Okay. If you see lack of fusion with a gap, then you have to measure the length of each fusion, and you have to add it, and you have to compare with 15 mm. At accumulative totals should not go beyond 15 mm. Then arc strike. Arc strike basically occur due to striking of electrode or due to electrical source that touches the parallel metal. It damages the parallel metal, and sometimes it damages the weld metal too. You can see this is a arc strike. It's occurred due to unskilled welder. Okay, if the electrode is strike on the parent metal, that is arc strike. You can always see the arc strike on the face of the weld. You cannot see at the root because you are welding on the face, not in the root. Okay. Then in group A, it's not permitted. In group C, in two place, it's permitted. Here on place, here also. If you see here also arc strike, then in two place it's permitted. If you have noticed in three place, you can reject directly in group C. And mechanical damage, any damage to the parent metal or weld metal, excluding any hot stamping and pop marks. This is a pop marks and stamping. Okay, you should not consider this as a mechanical damage. You have to omit. Okay, omit. And if you notice any chisel mark and the grinding marks and tag weld, stay tag weld, that is you have to consider as a mechanical damage. Okay, and this one you can see this is a tag weld. Always you can see the uh, tag weld in the root. No need to search in the face because it will be in the root only. Okay, don't waste the time to identify the face. Always it will be presented in the root surface. And chisel mark and grinding mark, that will be in both side, either root or face. You have to check in both the surface. In group A, tag weld is not permitted. Single tag weld also not permitted. Directly you can reject it. And parallel metal must be blended smoothly. If you notice any grinding marks or chisel mark, there should not be any sharp corners. All the sharp corners should be blended smoothly. If you noticed any sharp corners, that is rejected. And depth, okay, mechanical damages, that chisel mark or grinding marks are blended smoothly, but the depth is more than zero point 0.5, that is rejected in group B. Depth should be below zero point 0.5 mm. Maximum they are allowing zero point 0.5. And mechanical damages, they are allowing in only one location. Okay, here you can see no tag weld permitted. Okay, tag weld, single tag weld is not permitted, but they are allowing chisel mark or grinding marks if it's blended smoothly and also depth is less than zero point 0.5 mm in one location. If you notice more than a location, then it's rejected. Okay, in group C, one stay tag weld is permitted. They are allowing one stay tag weld. And that parent metal, if you noticed any chisel mark or grinding mark, it should be blended smoothly, then it's accepted. And then you have to measure the depth. If the depth is more than 1.5 mm, that is rejected. Okay, here you can see maximum two location they are allowing. Okay, two mechanical damages they are allowing in group C. Okay, if you noticed two tag weld, it's permitted. No, it's not permitted because they are allowing only one tag weld. Here you have to consider chisel mark and grinding mark for this criteria. Okay, maximum in two location they are allowing. Okay, I think you understood the this mechanical damages, about the mechanical damages. So you can see the mechanical damages either upper side, that is face side and root side. And penetration, the penetration, we can call it as excess weld metal in the root. If you noticed any excess weld metal above the parallel metal in the root of the joint, that is a penetration, which we are calling as the excess penetration, that is a penetration. So you can see here, this is a root area. You can see the excess weld metal. This is the excess weld metal. You can see this one. And here also you have to measure the height. So to measure the height, you have to check the plate distortion. If you have a plate distortion, you have to keep the gauge in the lower side of the plate, and you have to measure it. And the height should not goes beyond 2 mm. If it goes, then it's rejected in group A. In group C, maximum they are allowing up to 4 mm. Okay, I think you understood it. The next is lack of root penetration. If you see the two edges that is not filled with weld metal, there is a lack of root penetrations. The absence of weld metal in the root, and you are noticing that two root face. You can see here that edges, two edges you can see, and there is no any weld metal filled. There is a lack of root penetration. Here you have to measure the length. Here they have mentioned maximum length. Here no need to consider the intermittent, accumulative. No need to add that total length of the uh, root penetration, lack of root penetration. If it's continuously more than 5 mm, that is rejected in group A. In group C, continuously 15 mm. Up to 15 mm, it can be accepted in group C. If it's more than 50 mm, directly you can reject it. Okay, here you can see 29 mm. It's rejected in group A as well in group C. Okay, you can see the edges. Both the edges you can see with your naked eyes, and that portion is not filled with the well metal. There is a lack of root penetration. Okay, and lack of root fusion. Okay, no fusion on one root face. Here you can see that well metal is not fused on the face of the root. This is a face. It's not filled properly. You can notice near to the groove that's not filled properly. This is a root face. You can see there is no fusion. There is no well metal. It's not fused properly to the parent metal. So there is a lack of root fusion. You can see one portion, one face. It's not fused properly. Here also, if you notice in multiple places with a gap, then you have to measure the each length of the root fusion, and you have to add it and check with the criteria. Maximum 4 mm, either continuous or intermittent, they are allowing. If it goes beyond 4 mm, this is rejected, and in group C also maximum 25 mm, either continuous or intermittent, they are accepting. After that, if it goes beyond 25 mm, it's directly rejected. Burn through, burn through, you cannot notice in the well sample, so no need to worry, no need to mark it during the examination. Uh, you can see normally there's a collapse of well metal in the root. There's a burn through. You can see like a black color at the root. This is a burn through. So in group A it's not permitted. In group C, two in two areas are permitted. So this is a burn through. Okay. At last, we are going to discuss about root concavity. So root concavity always presents in the root area. If the well metal is below the surface of two parallel metal, you can see this is one parallel metal, and this is one parallel metal. That the well metal is below the surface of two parallel metal. There is a root concavity. Here you can see the root concavity, and here also is a root concavity. Okay, now your plate having misalignment. Okay, then you have to check properly whether it's having root concavity or not. Sometimes they will confuse you. Okay, you should be more careful, and you should notice that that weld metal should be below below the surface of two parent metal. Okay, you should be more careful while you have a, misalignment plate. Okay, and in group A is not permitted. Root concavity is not permitted, and in group C maximum 20 mm they are allowing. It should be continuous. Okay, if it's intermittent, and you should not calculate the total. If the root concavity is continuous and is more than 20 mm, then it's rejected. Okay, actually this practical exam is very easy if you understood the defect, and if you know how to identify it, then it will be very easy. You can crack the examination. Dear subscriber, uh, don't be panic. The exam is very easy. Comparing the previous pattern, now is very easy. Easily everyone can pass it. Before there is a three practical examination, that is very tough comparing to the new pattern. So no need to worry about that examination. The first thing, you should practice. You should practice well. You should know how to identify the defect and how to measure the uh, length or height of the defect. If you know how to measure it and how to identify it, you can crack the exam without any stress. So be practice regularly. So this is things about the examination. I hope you understood the video. If you like the video, just put the like button and subscribe my channel. We can meet in another one good video. Until bye bye, take care. See you. Bye.